Welcome in Dark Core. We owe the birth of life on our planet to the sun and its warmth, but our star is becoming brighter and its luminosity wasn't always what it is today. All indications are that in its first stages, the Earth must have been a ball of ice, no life forms there should have stood a chance, and yet evidence suggests water flowed and life blossomed. But this isn't the only cosmic paradox that remains to be explained. Is it possible for something to be older than the universe? Why should our sky look red, and how can dwarf satellite galaxies change physics once and for all? The red sky paradox: among all the stars in the Milky Way, 80% are red dwarfs or M-type stars that, according to scientists' calculations, may continue burning for trillions of years. To compare, the Sun will burn for about 5 billion years. So it's not surprising there are now more red dwarf stars than any other. With so many red dwarfs out there, our night sky should be dominated by their light, and at least some of them should host planets suitable for living organisms. So where are all the red dwarfs, and why haven't we found life in their systems yet? This is the red sky paradox, proposed by astronomer David Kipping from Columbia University. The way we view stars in space is different from what we would see through the Earth's atmosphere. From space, the sun appears white, massive hot stars appear bluish, and cooler stars appear either white or orange. Red dwarfs are so dim that even the nearest star, Proxima Centauri, cannot be seen with the naked eye. In telescope images, such stars can have different colors depending on the filters used. But the red sky paradox has nothing to do with the color of the universe, it's about the search for alien life. The idea is that planets in red dwarf systems have the best chance of developing life. Such stars live longer, and there are a lot of them. About 15% of red stars have Earth-sized rocky planets orbiting them, and most of these exoplanets are located really close to their stars, so they have plenty of light and heat, which also means there could be liquid water on these planets. And yet, life as we know it only thrives on Earth, which orbits a yellow dwarf. But yellow dwarfs make up just a few percent of the stars in our galaxy. So does this mean our star is special? Well, not exactly. The Copernican principle states that there are no privileged or special regions in the universe, in other words, our place in the universe is ordinary. But that doesn't mean life is ordinary throughout the universe. There may be some answer to this so-called paradox. Red dwarfs might be more dangerous to surrounding planets by flooding them with deadly radiation. These stars' gravitational forces are so strong that nearby planets are tidally locked to their star, turning one side into a red-hot hell while the opposite side is cold and icy. Planets in red dwarf systems also lack protection from objects coming from space. Open the NASA catalog and look for gas giants near red dwarf stars, they are extremely rare. Giants like Jupiter often serve as a sort of space defense in a star system. They interact with comets, asteroids, and other celestial bodies that can destroy or severely damage rocky planets. All this, according to Kipping, makes life 100 times less likely to occur in red dwarf systems than in yellow dwarf systems. Space is full of interesting stars, and one of them threatens to disrupt the accepted picture of the universe. 2. The paradox of the oldest star. The star named HD 140283 is located in the constellation Libra, about 190 light-years from Earth. Astronomers first determined the age of the Methuselah star when they used the Hipparcos telescope to measure its speed. They found the star moves 1.3 million kilometers per hour. But what surprised astronomers the most was the star's age, which was estimated to be about 16 billion years old. The result seemed very strange to scientists, given that the age of the universe itself is only 13.8 billion years old. So they decided to dig deeper. After 8 years, and with the help of the Hubble telescope, astronomers conducted studies by parallax, spectroscopy, photometry, and star luminescence. They concluded that HD 140283, according to new calculations, is 14.5 billion years old, but because it's extremely hard to precisely measure the star's distance and brightness, there's an uncertainty of 800 million years to its age. That means the star may well be 13.7 billion years old, meaning younger than the universe, although not by much. But what about the star that's much closer to us, the faint young sun paradox? According to the standard model of stellar evolution, 4 billion years ago the sun emitted about 30% less energy than it does today. With less energy reaching the planet, astronomers say that the Earth should have been frozen solid during these early times. But some scientists think this isn't what happened. According to the climate models of the Earth during the Archean Eon, 4,000 to 2,500 million years ago, the climate was about as warm and humid as it is now. There was no ice at the poles. Single-celled prokaryotes floating in bodies of water produced oxygen, which would later ensure the evolution of all life on the planet. Obviously, both of these scenarios contradict each other. Scientists say the planet stayed warm during this era, but how did it manage to do so? The heat could have come from the Earth's crust, which was still cooling after the planet was formed and gravitationally compressed. It's also likely that the heat was retained after a collision with a protoplanet, presumably the size of Mars. The result, the Moon, was created early. Tides between the Earth and Moon were very powerful. Because of this, the Moon became tidally locked in just 100 million years of its formation. Tidal heating could have raised the surface temperature of the early Earth and triggered volcanoes around the planet. Emissions of gases into the atmosphere as a result of such events created a powerful greenhouse effect. Most likely carbon dioxide and methane were the main contributors. In addition, there were almost no clouds in the Archean sky. They usually form when sunlight evaporates water, but there was very little light and thus very few clouds. The rare clouds reflected a minimum of the star's radiation into space. Enormous amounts of methane could have covered the sky with a thin photochemical haze, dyeing the clouds pink. This stunning show lasted until about the end of the Archean Eon. Then, because of the increasing concentration of oxygen in the atmosphere, methane oxidized and the clouds took on their familiar snow-white appearance. You've heard a lot of strange things happening in the universe, but strange things are also happening around our Milky Way galaxy. 4. The paradox of missing dwarf galaxies. According to the standard model of cosmology, large galaxies should have hundreds or even thousands of dwarf satellite galaxies around them. But so far, only 30 have been found around the Milky Way, roughly 1% of the predicted number. So where are the missing dwarf galaxies? One idea is that at some point in evolution, bigger galaxies could have captured these tiny galaxies by their gravity, or it could have been the result of some cosmic catastrophe. But perhaps we just haven't been able to track them all. More often than not, they're incredibly small and dim. Some contain only a few thousand stars. Meanwhile, the Milky Way holds 100 to 400 billion stars. With the brilliance of its stars, it outshines the modest reflections of tiny galaxies. The paradox of the missing Milky Way ultra-faint dwarf galaxies doesn't end there. These mini-galaxies challenge the entire Newtonian model of gravity. Their rotation is odd. In the cosmological model, satellite galaxies should form as individual objects before being captured by larger galaxies, and because they would be coming from different directions, they couldn't be arranged in a disk-like structure. But the 11 brightest dwarf galaxies are distributed exactly like that, and all galaxies rotate around the Milky Way in the same direction, somewhat similar to the way planets of our solar system orbit the Sun. According to scientists, such a layout could only be explained if gravity was stronger than predicted by Newton, and that's where the paradox arises. Scientists suggest dark matter clumps in these tiny galaxies aren't big enough to attract gas and form stars at all, so that would make them invisible to us. But it's dark matter that binds space objects together by its gravity, and there has to be a lot of it. Astronomers at Cambridge University have studied about 7,000 galaxies and found there's 400 times more dark matter there than normal matter. However, in May 2022, astronomers at the University of Barcelona in Spain announced the possible discovery of 11 galaxies devoid of dark matter. Inside dark matter galaxies, stars must move much faster than Newton's theory of gravity predicts. So if the data suggested by the Spanish astronomers is confirmed, Newton's theory will have to be modified. This wouldn't be the first time the fundamental principles of physics have to be changed, and such changes always lead to major shifts in the way we see the universe. Why do you think satellite galaxies in the Milky Way have managed to play hide-and-seek with astronomers for so long? What are our chances of finding habitable planets in small red dwarf systems? And what other space paradoxes would you like to hear about? Let us know in the comments. Thanks for watching Dark Core.